Hello, welcome to the lesson on how to differentiate trigonometric functions. Okay, so in this video we'll go through how to do the simple differentiation of sine, cos, and the remaining trig functions. Okay, once again, if you've not subscribed to my channel yet, kindly subscribe for more videos. Alright, let's start. So if I have a function like y, which is equal to sine of a function u of x, okay, and how do I differentiate this? Okay, you should take note clearly, because here is sine of u of x, so I can rewrite this as y is equal to sine of u, okay, where u is a function of x. Now if I want to differentiate this, remember we've done this video on how to do chain rule, okay, and I made mention that sine is a function on its own. Okay, so the sine sin that you see there is a function on its own. So the whole of this, I can represent the whole of sine u by something, okay, but one thing that you should know is that dy dx, okay, will be equal to what? You have to differentiate the sine function, and when you differentiate the sine function, you get cos of whatever that you have, the u of x. Then you multiply everything by the differential of u, okay, so you find u prime of x, which means du dx, okay, so I'll multiply it here, du dx, okay. So take note that whenever you differentiate sine of something, you get what? You get the cos of that thing times the differential of whatever that was in the bracket, okay. So let's take an example. An example is, if I have sine of, let's say, x, then what will be the differential of this? If this is equal to y, then dy d of x is equal to, when I differentiate sine, you say you get cos, okay, cos of x, but u is what? X. When I differentiate x, you get what? 1 from our basic definition. So this is equal to what? Cos of x. So whenever you differentiate sine x, you get cos x, okay. Now what about if I have y is equal to sine of 3x, okay, then dy dx, okay, is actually equal to, you said you write cos of whatever that was on the bracket, sorry, that was in the bracket, then you differentiate the bracket, and that will be what? 3. The bracket is u is equal to 3x. So when I differentiate this, I'll get 3. I hope this is cool, right? So that is how you differentiate sine, okay. Alright, what about if I have y is equal to, let's say, cos of u of x, okay. Alright, with this, the differential is dy dx is actually equal to negative, are you looking at this? Negative of the differential of the bracket, so du dx, okay, times sine of u of x. What this means is that when you differentiate cos, you get a negative sign, okay. So when you differentiate cos of something, you get negative sign of that, and then you multiply by the differential of the bracket here, the u of x, okay. So an example is, if I have y equals cos of x, that's the simplest you can get, okay. Dy dx is now equal to, now differentiate the bracket, what is in the bracket is x, so when I differentiate x, I get 1, okay, times negative sine of x. That is why we brought a negative first, okay. So we get negative sine x, because 1 times any number is the same number. What if I have something like y is equal to, let's say, cos of 2x, okay. To differentiate the function here, I'm coming to differentiate it down here. To differentiate that function, dy dx will be equal to, so when I differentiate the cos, what do you get? You get negative, okay, then sine of whatever that is in the bracket, 2 of 2x, okay, then times the differential of the bracket, which is 2. In this, if I rearrange, I'll get negative 2 sine of 2x, okay. So this is how come you differentiate your sine and your cos, okay. So alright, so if I have a function like y, which is equal to tan of u. So here you are also assuming that tan is also a function of x, okay? Then this is the same as sine of u over cos of u, okay? Now if you remember our second video on differentiation, we made mention of some rules of differentiation, okay? So we said if you have a function over a function, this is the same as what we discussed as u of x over v of x, okay? Now we said to differentiate this differential will be equal to v of x, okay? So you keep the down one, let me write it well. You keep the down one, okay? That v of x will come, then times u prime of x, meaning you differentiate a u, minus u of x, then times the v prime of x, okay? All over v of x squared. This is what we discussed, okay? So if you don't remember, I've just quoted it back. Now with this u of x, or u, let me write u, okay? U here is actually equal to sine of u, okay, and our v here is actually equal to cos of u. This u and the u inside the sine and cos, they are different, okay, please. Alright, then with that, what I need to know is what there is some u of x, u prime of x here, so I need to differentiate the sine of u in terms of the u prime of x, okay? So if I differentiate sine of u, I'll get what? U prime cos u. That is what we just discussed, that you differentiate it and multiply by cos u. Then if I differentiate the cos u, I get minus u prime sine u, right? So now let's put everything back in the general quotient rule, okay? Cos of u, and this will be equal to v of x is what? Our v is cos u, and u prime of x, u prime is what? That is differentiating the top one. The top one here is sine u. So if you differentiate sine u, let me use the red pen for you to see clearly, okay? If you differentiate sine u, we said you get this. If you differentiate cos u, you get this, okay? So this is our u prime of x, and this is our v prime of x, okay? So now if I put u prime of x is u prime cos u, okay? Then minus u of x is what? Sine of u into v prime of x, which is minus u prime sine u, okay? All over v of x is cos u, so cos u all squared, okay? Now this will give me cos u times u prime of s cos u. When I multiply through, I get u prime of s out, or u prime out, then cos squared of u, okay, plus, because there's a negative inside this here, okay, that negative sign, so it becomes plus, okay? Then sine u times u prime sine u becomes u prime sine squared of u, okay, all over cos u all squared. Now we can do some factorization here, okay? Let me clean the top for you to see. So with this, factorizing this down here, you can see that the whole of this differential will give us u prime of x is here, or u prime is here, u prime is also here, okay? So we'll factor that out, and we'll get this being equal to u prime out cos squared u, okay, plus sine squared u over cos squared u, because cos u all squared is the same as cos squared u. Now this will give me u prime of x, and cos squared u plus sine squared u is what? 1 over cos squared u. Okay, this is equal to u prime out 1 over cos u all squared. This is possible because of indices, okay? So cos u all squared 1 over cos u squared can be represented as 1 over cos u all squared, okay? So now from this you could say that this is equal to u prime then 1 over cos u is what, sec of u squared. Now this be equal to u prime of what, u prime sec squared u. So that's why in some books they will tell you that the differential of tan u is sec squared u. So now let's take an example. Alright, I hope you understood the process. If I pick tan of x, okay, u is what, x, u is just x, so u prime will be equal to what, 1, sake of, or because u is what, x, okay. Now we are saying that dy dx in terms of y being equal to tan x, okay, will simply be equal to u prime, which is 1, times sec squared of u, which is x, okay. But is equal to sec squared x. That is why in books they will always define it like the differential of the differential of tan x with respect to s is a squared x, okay. But know the process. Alright, so now what if y is equal to, let's say, tan of s squared over 2, okay, something like that. Here u is what, s squared over 2, so u prime will be equal to 2x over 2, okay, and u prime will be equal to what, x. So now our differential dy dx will be equal to u prime, which is what, x, then sec squared of what, s squared over 2. This is very, very simple, right? So if you know how to do this, it will be at your fingertips and it will help you solving your exams problems, okay. Alright, let's move on to a different function, cotangent, okay. Alright, so if I have a function like y is equal to cotangent of u, where u is a function of x, then it means that my dy dx will be what, so this is equal to cos of u over sine of u, okay. So here we'll use the basic idea. Let me use a big pen rather, okay. So we use the idea that we know from the basic the previous video that we did on rules of differentiation. So here there's a function over a function. So we said if you have u, or let's say f over g, let me use that rather, okay. We have something like f over g, where all of these are functions of x, then dy dx is actually equal to f prime times g minus g prime times f, okay, all over g squared, okay. So here our f, let's say our f is what, cos u, then our f prime will be equal to negative u prime of sine u, then our g is what, sine u, then our g prime will be equal to u prime cos u, okay. At this stage, differential of cos and fan should be at your fingertips, okay. So with this, dy dx from the main function, that is this side, is actually equal to, now our f prime is what, minus sine u, so minus u prime sine u, okay. So it's minus u prime sine u, then times our g is what, sine u, okay, then minus our g prime will be what, u prime cos u, times our f, which is cos u, all over sine u all squared, okay. Now this will give us, I'm writing at the top there, u prime sine squared u is minus rather, okay, minus u prime cos squared u all over sine squared u, okay. Now this will be equal to minus u prime out, okay, sine squared u plus cos squared u, I hope you can see this, all over sine squared u. Now sine squared u plus cos squared u is what, 1, so we can minus u prime times 1 over sine squared u, okay. Now let me put a bracket here. It will be equal to minus u prime times 1 over sine u all squared. Okay, so this is what we've gotten. All right. Okay, so now if this is what we've gotten, then I mean the differential is equal to minus u prime. What is 1 over sine? It's cosec. Okay, u then squared. So this is equal to minus u prime cosec u cosec squared u. Okay, sorry, it should be cosec squared u. Okay. Alright, so let's solve an example. So an example is y is equal to, let's say, cotangent of x. Okay, now our u is what? X. So u prime of x is equal to 1. Then dy dx is actually equal to what? Negative, there is a negative here, times u prime. Okay, this side, yep, mimicking the formula here. U prime is what? 1. Then times cosec squared of u, which is x. So everything become negative cosec squared x. Okay, what if I have y is equal to, let's say, cotangent of 2x or 2s squared, let's say this, then u is what? 2s squared. So it means my u prime will be equal to what? 4x. Therefore dy dx will be equal to negative u prime, which is minus 4x, times cosec squared of u, which is 2s squared. Okay, I hope this is okay. Alright, so this is how you differentiate your trigonometric functions. So let's look at the inverse trig function, that is, sorry, not inverse actually, but the reciprocal of them. Okay, we'll look at the inverse later on. So let's look at how to differentiate 1 over sine x, 1 over cos s as well. Okay, so what if you have y is equal to 1 over sine x? Okay, alright, so this is the same as sine x all to the negative 1. Okay, please, this is different from sine inverse of x. Please just take notes. Okay, alright, if that is the case, then using the chain rule, if you remember, we did some chain rule previously that we said if you have y equals u of x all to some power n, then you have to differentiate y with respect to n. So you just say u of x, the whole of this u of x is equal to, let's say, some k, so you get y is equal to kn. Then you find dy dk, which is equal to n k to the power n minus 1. Then you come and find the k dx or du, or let's say, since k is representing something in s, you find that one. Then after that you multiply by dy dk. Okay, that will give you dy ds. Okay, so that is the same thing here, because here if you let some k be equal to sine of x or sine of u, okay, we will write a generalized function to it. Okay, actually you have to make it generalized, but I'll give a question on generalized one. Okay, then y would actually be equal to k to the negative 1. Okay, because the sine of x all to the negative 1. Then what we should do is find dy dk, and we said in differentiation multiply the original power by the front, and that will be k negative 1k times k to the negative what? 2, because you subtract 1 from the power. Okay, now you come and find the k dx, and the k dx will give me what? Differentiating sine of x is differentiating the x with respect to s, you get 1. Okay, times differentiate the sine, you get cos, so this is equal to cos of x. Okay, so in other words, this is the same as dy dx is equal to the product of these two. Okay, now mind you, this one is the same as negative k to the negative 2. Okay, so if I multiply the 2, I'll get negative k to the negative 2 cos s. Okay, and this will be equal to negative cos s over k squared. Okay, and what is my k? So I get negative cos x over, what is my k? My k is what? Sine. So we become sine squared x, or sine x all squared. Okay, so now let's look at something. Let's try to break it down. Okay, so now with this side, the down here, we get something like negative cos s, okay, over sine x times sine x. Okay, I hope you can see that because it is squared. So this is equal to negative cos s over sine x times 1 over sine x. I hope you can see that. Now what is cos s over sine x is what? Cotangent. And what is 1 over sine x? The same as cosec. Okay, so this is the same as negative cotangent of x cosec x. Okay, which is the same as negative cosec x cotangent of x. Multiplication is commutative anyhow you write it. Okay, so this is the differential of 1 over sine x. Okay, that is dy dx is equal to that. Alright, what if the function here is not x but is, let's say, something else? Okay, so let's say y is equal to 1 over sine x is cosec s, so I'm just writing it straight. Cosec, then instead of x you get s squared plus 2x. Okay, how do you differentiate this? Now what you do is that you first dy dx is equal to, now you first differentiate cosec, and what will you get? You get negative cosec, look at here, we're just writing it from here, negative cosec of whatever that was in the bracket, which is s squared plus 2x, then you get cotangent of s squared plus 2x, then you multiply it by the differential of this bracket, which is into bracket 2x plus 2. Okay, so in other words, this whole differential is equal to negative, I'm bringing a 2x plus 2 in front, 2x plus 2, then times cosec of s squared plus 2x times cotangent of s squared plus 2x. Okay, so that will be your differential. Okay, so always just keep it in mind. If you are given a function to differentiate, find out if the function operator, that is the sine or cos or cotangent or cosecant, is being operated on function other than x, something like s squared plus 2x that we just did, this one. Okay, then you have to differentiate the bracket, multiply by the differential of the trig identity. When you differentiate cosec, you get what? Minus cosec s cot s. Alright, now let's go and look at 1 over cos s, and that will be for it in this video. Okay, alright, so what if we have y is equal to 1 over cos s? Okay, which is the same as secant of s. Okay, but I'm writing it this way so that we know how to differentiate it properly. Okay, cos s all to the negative 1. Okay, so now with this, how do we differentiate? The same thing. Okay, so the same thing, what you do is you let your k be equal to, let's say, cos s. Okay, then it means that y is actually equal to k to the negative 1. Okay, so you find the y, the k, and that will give me what? Negative k to the negative 2. I hope you can do this integral very fast. Okay, so now with that, I have to find my dk dx, which is equal to negative what? Sine of x. Okay, I hope you remember this. Alright, so with this, I just have to multiply them to get my dy dx. Okay, so now the whole of this dy dx will actually then be equal to negative k negative 2 times negative sine of x, which is equal to negative you get positive, but I'm writing the sine of x first. Okay, you get the sine of x first, then k to the negative 2, which is the same as sine x, okay, over k squared. Alright, so now with this, it means our dy dx is equal to sine of x over k is what? Cos of s all squared. Okay, so now this will be equal to sine of x over cos of x times another cos of x. Okay, so this will be the same as sine of x, okay, over cos of s dot 1 over cos of x. Okay, so now with that, sine of x over cos of x is what? Tangent of x, and 1 over cos s is what? Secant of x. So this whole thing is equal to secant of x cotangent of x, sorry, tangent of x rather. Okay, So this will give us sec x tan x. Okay, so you see in most books that whenever I differentiate secant of s, you get sec s tan x. This is how you go about it. Okay, so like we did for the cosecant, if the bracket is not just x, you know how to go about it. Okay, so if I have the integral of 1 over cos of 10x, okay, is the same as y is equal to secant of what, 10x. Okay, so now how do I differentiate this? Okay, the differential is dy dx. Let's code the formula. Is equal to, now differentiate this bracket, you get 10, and differentiate the secant, you get what, secant of 10x, then tangent of what, the same 10x. That is how you go about it. Very, very cool, right? Okay, so if I have something like y is equal to, let's say, secant of ln x. Okay, I'm just trying to make this big for us. We've not done ln x yet. Let me erase it. When we do it, we'll mix all these. Okay, so that is it for today's lesson. Kindly subscribe to the channel if you've not subscribed yet. Let's promote this channel for people to also understand mathematics and appreciate it as well. Thank you, and see you next time.